students, welcome to class 12 physics class. Today we start another one new chapter, that is alternating current and electrical machines. Chapter number 7. In first chapter we studied about the electrostatic, current, electricity, everything related to electricity. And we know that we can't live without electricity. And did you know that the electricity which is entered in our house, that is a different kind of electricity, and that current is called alternating current. Yes, this chapter we discuss about this alternating current. This electricity is generated 100 miles or even 1000 miles away. It is used by you to run your computers or charge your smartphones. But this kinds of current are in physics, it is called alternating current. So in everything related to alternating current, we discuss in this chapter. So first we have to understand what is an alternating current. Alternating current and direct current, two types of current we have. Direct current which flows with a constant magnitude in the same direction. Its magnitude also be same and its direction also be constant. It can change its magnitude and the direction. That type of current is called direct current. But alternating current, the answer is hidden in this word, altered. That means its magnitude continuously changes with time, and the direction of the current also get reversed periodically. Here in this graph, this is a sine graph, you see that the magnitude also be changes at 0 at the then it increases at the maximum value peak point. After that it will decrease it, then again 0, then it direction changes reverse. In a negative side it also get up to the maximum value, then it will be again it comes to 0. So periodically with its magnitude continuously changes with time. As the time is goes on, its magnitude also be sometimes it is increased up to the peak point, then it will decrease to 0, then its direction will be changed. In the negative side same thing, increase up to maximum height or the peak point, then it will be decreased to 0. So this kind of current are called alternating current. This is called alternating current. Short form we say that AC. Alternating current, AC, direct current, DC. Okay, it's in that thing is that whatever I discussed, that 0 to is peak value, that means the maximum value. So in case of alternating current, it's changing its magnitude at every instant of time. The direction of the current will be clockwise and anti-clockwise, and it will keep on repeating. Frequency of alternating current is defined. Frequency means what? Number of oscillation per second. That in here in the terms of electricity, how fast the electrons are changes their direction. That means it will reverse after certain time, it will reverse its direction. So how fast they will changes their direction, that is called the frequency. For example, the frequency is 20 hertz. That means the electrons are moved back and forth. That means they will change the direction for 20 times in a second. Clear? Okay. So DC voltage gives rise to DC current. Similarly, AC voltage also gives rise to AC current. Alternating current is expressed. Alternating current is expressed or when a coil is rotated in a magnetic field, and alternating EMF is induced in it, and due to that EMF we get an alternating current. So alternating voltage or alternating EMF or alternating current can be expressed in terms of sign. So I equals to Im, that is a maximum value, but we use I0. Okay, here it is written because maximum or peak value we say that, that's why I will write Im sin omega t. But after that, whatever the derivation is there, we denoted this maximum value or this peak value of AC, that is by I naught. In your NCERT book, that is also denoted by I naught. That's why we use I naught in place of M, V naught, I0 or I naught. So similarly, alternating voltage, V equals to Vn sin omega t. In place of M, we also use the 0. or not V naught sine omega t. In case of EMF, E equals to E0 sine omega t. This is a difference between direct current and alternating current. Already we get two difference. One is its direction constant, cannot change, but its direction will be reversed periodically. In direct current, its magnitude is constant, but the alternating current magnitude varies with time. Direct current we get from the batteries, and alternating current cannot be stored, and direct current can be stored in the batteries, alternating current cannot be stored. Example, that battery gives us a direct current, the alternating current get V from generator and the electrical mains. Clear? Okay. So from Ohm's law, we know that I equals to V by R, or in terms of EMF, E by R. So in place of E, if we write E0 by R, that E0 by R denoted I0, and that is called, I0 is called maximum value of AC, and it is called current amplitude. Okay, so amplitude, that is a maximum value attained by an alternating current in either direction, is called its amplitude or peak value, and it is denoted by I naught. Clear? Okay. So and the whatever the alternating current it is supplied to our houses, it has a frequency. Its frequency is fixed. It has a frequency that is 50 hertz. That is 50 hertz. So as the alternating current is positive in one half cycle, equally the whatever the value in the first half, same half but in a reverse on the other half, equally negative in a other half cycle. So the mean value over a complete cycle, that will be 0. If it will get in a positive half, that is +5, in the negative half also we get the -5. Magnitude is same but the direction is different. So that's why total mean value +5 -5, that will be 0. And this can be proved mathematically also, that the average value of AC over one complete cycle will be 0, and this is shown here. This derivation is shown here. So we use the alternating current expression, I equals to I naught sine omega t. Here we assume that the current remains constant for a small time. If we see that if we consider that any instant of time, we get that expression I0 sine omega t at any instant of time. If time fraction will be very small, so we can consider in that small time the current also remains constant, same current. So we can write dq equals to I into dt, because I is constant for small time dt. So dq equals to I into dt. So in place of I, if we put this expression I0 sine omega t into dt, now this is for that small time dt. Now if we want to get the total charge flows through the cycle, one complete cycle of AC, then Q equals to V integrate both sides. So total cycle, complete one cycle, that means the time period 0 to t. Its limit taken 0 to t. So if we integrate sine omega t, we get minus cos omega t by omega. If we put it over there, omega means we know that 2 pi by t. Omega is the angular frequency, that is equals to 2 pi nu, and nu means 1 by t, so we can write 2 pi by t, capital T. So inside also we replace omega by 2 pi by t into t. Now in place of small t, first we put capital T, then we put the 0. So if we put first capital T, then capital T cancel, so we have only cos 2 pi minus cos 0. So we get its value will be 0. So the average value, so this will get that the current, that the total charge flows through the circuit in one complete cycle, that will be 0. If charge is not flows through the flows, there will be no charges, then how can we get the current? So the current I equals to Q by T. If Q equals to 0, then I equals to also be 0. So it is proved that average value of AC over a complete cycle, that is 0. Okay. Now one thing before we discussion this average current mean value or the average value of AC for half cycle, that is for full cycle. If the half cycle, positive half cycle or either the negative half cycle. So before that we have to know that the ordinary moving coil galvanometer, that is did not use to measure the AC, because it is based on the magnetic effect of electric current and which is depends direction of current. So it cannot be used to measure the AC, because during half cycle of AC its pointer moves in one direction, during next half it will move in opposite direction. So the average value of AC over the complete cycle is 0. So even if we measure the alternating current at a low frequency, the pointer remained, it will be a stationary, it will not show any deflection. So we measured AC by using a hot wire ammeter, and this device is based on the heating effect of electric current, and this effect is independent of direction of electric current. So there will be no difficulty to for the pointer, the deflection of the pointer, it will deflect in a one way. Okay, now we discuss the mean value or the average value of AC for half cycle. So how can we define the mean value or the average value? It is defined that the value of direct current which sends the same charge in a circuit in the same time as is sent by the given alternating current in its half time period. Half time period, full time period. Full time period means one positive half, one negative half. Total that will be a complete cycle. One complete cycle. Half cycle means either it will be a only positive or the negative. So that's why it is says that the alternating current of the half time period, and it is denoted by Im or I average. That's why I told the Im we did not use for the maximum current, we use for peak current or maximum current I naught, because Im it is used for mean value and the average value. So there, what is the relation between the average value and the peak value of AC? That means Im and I0. What is the value relation? There will be also different derivation. We use the same equation, I equals to I0 sin omega t, and we also consider same that for small time dt the current will be constant. So dq equals to I into dt. So in place of I, if we put I0 sin omega t into dt, now if we want the total charge flows through the circuit in a half time period for the in the first half cycle. That means t equals to 0 to t equals to t by 2, not capital T. Capital T is the total time period. So half time period, that means capital T by 2. So limit also we use 0 to t by 2. Now after integration we get the value I0 into t by 2 pi. You just do this in your copy in your home. Write this equation, write this integration, then you integrate it, you get this value I0 into t by pi. Q equals to I0 into t by pi. So this is a value of Q. That means we get a value of charge. So if charge is present, that means the current also be present. So I average or mean value of current, that is equals to charge by time. So Q by t by 2. So now if we put the value of Q over there, we get I0 to I0 by pi. 2 I0 by pi. Now the value of 2 by pi, that will be 0.637. So the relation between average value and the peak value, that is I average or Im, that is equals to 0.637 into I naught. Similar value we get for an alternating voltage also, or alternating EMF also. Same. You can also prove these things. In here we find out the alternating current. In place of I, you can write E by R. So you get the expression in terms of E. So if you derive that things, you also get E average. If you you do once in your home, if you have facing any problem, write in a comment box that you did not get this value in case of a E average. So I will do that derivation in my copy and I will send it to you. Okay. So similarly, we can get the for alternating EMF that E average or EM, that is equals to 0.637 into E naught. But derivation is not included here. Try to in your home. If you are facing any problem, let me know. I will give you that derivation. Next, this all are the all this mean value, average value, root mean square value. These all are important to measure the AC. To measure the AC, we define the mean value of AC over half cycle or its root mean square value. These are the important things. Okay. Now, root mean square, or in short form, it is called RMS value, or it is called virtual value, or it is called effective value. Three names are there. Root mean square, that is called RMS, root R mean M square, that is RMS value, or virtual value or effective value of AC. So what do you mean by RMS value? RMS value, it is defined as the value of a direct current which produces the same heating effect in a given resistor as it produced by all given alternating current when it burst for the same time. Okay, this is the definition of virtual value or the effective value or the root mean square value. The value of a direct current which produces the same effective heating effect in a given resistor as it produced it by given alternating current when passed it through the same time. It is denoted by IV, I effective, EFF, I RMS, anything you can write. So these three are equal, same, meaning is same. IV, I RMS, I effective is same. What is the relationship between the effective value and the peak value of the current IRMS and I0? So here, because in the definition it is mentioned that is a heating effect of electric current. So here we use the term that is heating effect. So we use H. Okay, so we know that the alternating current I equals to I0 sine omega t. It is flows through a circuit which resistance is R. Then because the heat is generated, so heat will be generated in a small time dt, because in small time dt current remains constant. We consider that's why we use this small time dt, this word small time dt, the small amount of heat is generated. So dh equals to, from Joule's law, I square RT, so I square R into dt. So now if T is the full time period of AC, then the heat produced in a complete cycle, we integrate both sides. Integration of dH, we get H, integration 0 to T, I squared R into dt. Okay. Now if I effective be the either you can write I effective or IV or IRMS, anything you can write. Okay. Here it is written as a I effective. Now if I effective is value is the AC, then heat is produced in time T, that is H equals to I effective square R into T, because this will consider at a full time period, that's a full time T. So if we compare this to equation, first and second, both are the equation of H. So we can write I effective square RT, that is equals to integration of 0 to T I square R into T. That integration we get from that small dH. But if we consider the whole time, then we get the third number equation. So after integration, we get I effective square, that is equals to 1 by T 0 to T I square into dt. Now this term I by T 0 to T, this is the mean of square of the instantaneous value of AC over one complete cycle. So I effective equals to root under of these things. So we have to find out this integration value. So this is integration value. Integration is done here. Integration of 0 to T I square dt. In place of I, you can write I0 sine square, I0 square sine square omega t. Now if you integrate it, you get the steps, and at last you get this one I0 t by I0 square t by 2. That is only for that integration value, but 1 by t another one is there. So I effective equals root under 1 by t into I0 t, I0 square t by 2. So t cancel, we get I0 by root 2, and 1 by root 2 value is 0.707 into I0. So this is the relationship between IRMS and I peak value of current. Okay, after this derivation, this integration, you once you practice in your home, in your copy, otherwise you did not remember these things. Okay, similar value also we get for the EMF also, just we replace I by E by R. In place of I square, I equals to, you can write I square equals to E square by R into dt. So E equals to E0 sine omega t. So same way you can derive it, integrate it, you get the same value, E0 square t by 2R. So you get ERMS equals to E0 by root 2, that is equals to 0.707 into E0. try to in your home this derivation in terms of EMF. Okay, so these are the two relation with the peak current. One is the I average, another one is the I RMS. This is one numerical, and here directly we use the relations. Is equals to root 2 into ERMS. The values are given. Here also we use the same thing. Okay, in place of omega we can write 2 pi into f, or in case sometimes it will write 2 pi into mu. So just try it on your home. Okay, so if you are facing any problem, please keep it in your mind one thing: these derivations are very easy derivations, but if you are not practice it, you cannot perform or you cannot write in a examination hall during the examination period. So please, once or twice, at least 2 to 3 times, you practice in your copy just the derivation step by step, this integration procedure. Don't write down the statements, only you practice the derivations, that integration procedure, that you get or not, that in case of a half cycle, that e derivation is not there. So try to in your home. In place of I, you can write E by R. This same thing for the RMS value. Please, so please, it's my request to everyone, please, in your copy you try it once. You do this in your copy at least 1 to 3 times, 2 to 3 times. Otherwise this derivations, this chapter is very easy, derivations also very easy. That means this means it's not that you are not practice it. If you are not practice anything, you cannot perform well. So if you have any problem, facing you any problem in any derivation, and that E value, that average value of E over a half cycle, you get the same value or not, that is also your homework. Okay, so let me know. Okay, if you are not if you are having any problem to solve that one, so please write in a comment box. So I will do that derivation in my copy and I will send it to them in the group. Thank you very much. Have a nice day. Tata, bye bye. Stay safe. Stay in your home. Bye. Have a nice day.